Hello everyone, welcome back to the stream. So today we're gonna continue following the Vulkan tutorial. And last time we were working with uniforms. And if you check out the current status of the program, you can see that we have the regular rectangle, but we were playing around with matrices. And we had the option to, for instance, rotate the model matrix. And that would basically rotate the rectangle. As you can see, we are able to rotate the cube using uniforms. What we were missing is to animate the rotation over time. So if we go back to the uniforms chapter, we can try to find this part of the code where I maybe search for time. Yeah, they created this update uniform buffer function, which basically takes the current time and subtracts it from the starting time, and then uses this difference to basically animate the rotation of the cube, or the rectangle in this case. So we need to figure out how to do this in Rust, and I really don't know how, so I will just check the documentation. Rust get current time, maybe. We have system time. There's also the nursery, some documentation there. Measure elapsed time. Maybe this one. So they are importing duration and instant from standard time, and then we can get the current time with instant now, and we can do some other stuff, and afterwards just call elapsed on the instance that we got. So I think that could work for us. So let's give it a try. We need to import duration and instant. So I can add them here at the top. They are from the time module. And then somewhere in our program, we will have to compute the initial instant. So they are using a static variable here, which is like using a global basically, but with local scope. So, but we will just add a new variable basically wherever we need the time for the first time. So let me see. I think I had a comment. Main loop. So here, before we start the main loop, maybe we can get the current time. And here they call it start time. I think we can rename this to start time as well, to be more specific what this variable is for. And then after a while we can check the elapsed duration basically. So let me take a look at this in the documentation. So instant now returns this structure type instant, and then we have different methods. Among them we have elapsed, which does return a duration. which is a different structure, right? We have instant and we have duration, and we will probably have to convert this duration into seconds or milliseconds. We have a few methods to convert a duration into other units. So I think I know more or less how to do this. So we grab the start time, and then when it comes the time to update the uniform, before updating it, we call start time elapsed, which gives back a duration. And then we can maybe do a sex F32 should be enough precision, I think. And assign this to seconds elapsed, something like that. What are they doing exactly here? They get the current time, start time. So I'm not sure if this is going to be exactly what they are doing, but we can give it a try. And now we can just generate a rotation using the time multiplied by 90 radians. Well, 90 degrees converted to radians, which is pi divided by 2. So let me comment back this. So here we were doing pi divided by 4, but we can go back to pi divided by 2 and multiply this by the seconds elapsed. And let's see if that gives us the result that we want. And we have a rotating cube. Maybe it's going too fast. I think it's going too fast. So let's go back to divided by 4. So yeah, we managed to do it. We can now get rid of this to do, remove this as well. And we were getting a warning that duration is not used because we directly get it as seconds, so we can get rid of that import. Delete this and that, and this should still be running. Looks good to me. Oh, what changes did we introduce? Pretty simple, I would say. But I think it's worth committing this separately. So, rotate. Animate the rotation using the elapsed time. Okay, so that being done, we can move on to the next chapter, which is all about textures and texture mapping. So we'll see how does this work? Because so far we've been using colored colors per vertex, which is rather limiting. So in this part we're going to implement texture mapping to make the geometry look more interesting. This will also allow us to load and draw basic 3D models in a future chapter. Adding a texture will involve the following steps. We need to create an image object backed by memory. Then we need to fill it with pixels from an image. We also need to create an image sampler. And we need to add a combined image sampler descriptor to sample colors from the texture. This last one sounds a bit complex, but we'll get to it. So we've already worked with image objects before. Right, the ones from the swap chain. We're already getting images from the swap chain and then creating image views. But now we're gonna have to create images ourselves. So we'll create a staging resource, we'll fill it with pixel data, and then we copy this to the final image that we want to use for rendering. Although it is possible to create a staging image for this purpose, Vulkan also allows you to copy pixels from a BK buffer to an image. And the API for this is actually faster on some hardware. So we are going to create a buffer, fill it with pixels, and then copy that to the image. And creating an image is relatively straightforward. It involves querying the memory requirements, allocating device memory, and binding it just like we've seen before. However, there is something extra that we'll have to take care of when working with images. Images can have different layouts that affect how the pixels are organized in memory. Due to the way graphics hardware works, simply storing the pixels row by row may not lead to the best performance, for example. When performing any operation on images, you must make sure that they have the layout that is optimal for use in that operation. We have already seen some of these layouts when we specify the render path. So yeah, we already seen some layouts for optimal for presentation, optimal to work as a color attachment, for writing color from the fragment shader, optimal as source in a transfer operation, or optimal for a destination in a transfer operation, and also optimal for sampling from a shader. So we have several kinds of layouts, and one of the most common ways to transition the layout of an image is a pipeline barrier. These are used for synchronization access to resources, like making sure that an image was written to before it is read. But they can also be used to transition layouts. So we'll be using those pipeline barriers. Barriers can additionally be used to transfer queue family ownership when using BK sharing mode exclusive. Okay. So next, what do we have? Image library. There are many libraries for loading images, and you can even write your own to load simple formats. This tutorial will be using the STV image library from the STV collection. Yeah, if you don't know the STV collection, the STV image library, it's very easy to use header-only library. You can find it in here. And they are going to use this for C and C++. The problem is that we are using Rust, so we'll have to see how do we deal with this. I think in the future I'm gonna want to write my own image loading code, but for now I will try to compile this into a static library and then try to link with it and add bindings for it. Well, this for now. So let's see if we can manage that. We need to get the STB image source code, and we can grab it here. And then I'm gonna make a new file. Basically source, make it on the root directory, stdimage.c, which just includes std image. And if I'm not wrong, we need to define. I downloaded it as HTML apparently, so that's not good. We need to get it as raw. I basically downloaded this GitHub page. Why is it so slow? Copy link. image.h, and we can download it again. Now we got the right version. Yeah. And what I was mentioning before is that we need to add this STB image implementation before we include STB image.h. Otherwise, it will like a header only. It will not contain the implementation. And since we want to basically create a static library with the whole code, we need to add this. So something like this. And now if I just compile this and maybe save it into stdimage.o. And define reference domain. How do we compile a static library? See, compile static library. I've done this in the past apparently. So what are the compiler flags? So is it that we need to specify the C flag? Maybe. Maybe. Okay, now what do we have in here? We have the source code, the header, and we have this object file. And we can next create a static library. We need to use the archive tool, RCS, and then we just specify we just have to specify the name of the output that we want. I think I got it. So we specify the name of the library, which I'm gonna set as libstd image.a, and then the input object files image.o. And then we have this libstd image. I check which kind of file it is. Doesn't say anything. Well, current AR archive. Symbols or anything? Yeah. And we can check all the symbols that this thing has. And we should even have a grep stbi load, I think. Yeah. So yeah, we managed to make basically a static library. I'm gonna save all these commands that I typed. Basically, this one. This one into maybe compile. This we were using it for the shaders, but we're gonna basically code for compiling STV image as well. And the other command that we were using is gcc we can say compile STV image, compile our shaders. I don't have a shebang in here, so better add it to be POSIX compliant. So let's give it a try to just run this. And if I remove libstd image and stv, well, everything with an O extension. And now we just have stbimage.c, stbimage.h. And if I run compile again, and we have again the library. I will add into our git ignore that we don't want to commit any neither object files nor lib files. Sorry, static libraries have the .a extension, at least on Linux, so we don't want to commit any of those files. Okay. What next? Okay, next, let's go into source lib, and I will add a new module, std image, and use everything from it. Yeah, sure. And then we will create the corresponding source file, stdimage.rs. And here we can add a extern C block. And here we're gonna link with std image. Basically the same that we are doing for xlib bindings, all this stuff. We want to do the same for the std image. Now we have a static library, so we should be able to call functions from it. And the one function that we are gonna be using, if they say it somewhere in here, should be to load the image, basically. Do they use std somewhere? std. They are including, and yeah, they are doing what I was telling you above before. We need to specify this to compile it, not only include it. And what else? They use this std load function, which returns the pixels std_uc. So we need to add this to our bindings, pub fn std load, and I'm gonna open up the actual library and search for it. std I load. There are many variants of this one, but the one we're interested in has takes the file name as a constant char pointer, then it outputs the x and y. Not sure if it's x and y or maybe more appropriately width and height, but anyways, doesn't matter. We have x, which is a mutable i32, and y, mutable i32. We also get back the channels in file. I'm gonna reduce this to channels. And we can also specify our desired number of channels. And this returns basically a mutable pointer of std i_uc, whatever that is. So we're gonna have to define this type std i_uc. It's just type def for unsigned character. So std i_uc is just a UI like this. Do we need anything else from std? We use std load. Do we have to free? Yeah. std image free. Let's add also this one. Which if we search for it, it returns void. And it takes in the I like this name, red val from std load. So yeah, whatever std load returns must be freed with this function. And I'm gonna keep the name, red val from std I load. Not sure if I want to keep it as a void pointer to be the same as in the definition, or just return Let's just take an STBIUC unsigned character. I'm not sure. Okay, let's silence these warnings. Allow non-camel case. Non-camel case. What's it called? Non-camel case. No, I can't. What is the exact one? Non-camel case type. Non-camel case types. Like this. And now we don't get the warning anymore. Let's quickly check that this compiles. Because we are linking with a static library. Yeah, we get a bunch of warnings about unreachable things, but it seems to be compiling, surprisingly. So back to main, we should be able to load an image. And maybe we can use this same image that they are using. Do they provide a link somewhere? Create a new directory. We're going to load. Maybe at the end of everything they provide the link. No? Maybe I can download this one, copy the address, and I'm gonna also create a texture directory like they're doing. Textures. We have that JPEG file, so we should be able to load it now. That's the first thing they are doing, right? They are creating, after creating the command pool, create command pool. They have this create texture image, and the first thing they do is load the image using STB. And we need pointers to take the width, height, and the channels. So let's try to do the same. So we're gonna have width. We can initialize them to 0, red height, red channels. Then we get the pixels from STB load, and it takes the path to the file name, textures, texture.jpg, takes a mutable reference to the width and a mutable reference to the height and the channels. And do we need to specify how many channels do we want? They are using this constant. This is just 4, so let's just use 4. No need to overcomplicate this adding the numerations. And I'm curious to see if this worked. So load image. Maybe have this times this channels with 5 channels and give it a try. Run. Of course, this needs to be converted to a C pointer. I had a function for this as a sister or to system. I had it at the top. Where is it? Sister to string. It's just to convert from a C string to a Rust string. So it doesn't work for us here. We need to have this basically. It needs to be null terminated and then as pointer. And since as pointer of a byte slice returns, it's to be basically this. Cannot find LSTD image, no such file or directory. So even though this was compiling, it is not able to find the static library, I think. Would it work if I where is it? It's here. Would it work if I copy libstd image into source? So now in source we also have it. No. Cannot find LSTD image. Do I have the name wrong? Maybe. It's gonna be tricky. Rust link with static C library. Dependencies. link name kind static. So can I try this in here? Is this better? Cannot find native static library std image. Perhaps an L flag is missing. I want to search in user lib. Do I need to specify first the name? Should be. I don't need the. I don't need the equals. Yeah. If I get one of those and I don't know, libelf and check which kind of file it is. It's the same that we get for libstd. Current archive, AR archive. So is there a way we need to specify Rust where to find the library? We use a build script to set the value of Rust link search to point to the directory where I put the library. And it needs to be an absolute directory. You could also use the build script to specify which library to link instead of having it in your code. Yeah, and they mention things that we should be doing, but I'm not gonna do them for now. So if we add link catch, create type, Trust middle scripts. Do they go inside of source or? Just want to know where should I place the build arrays. Links. So maybe we need to do that as well. And we can override. So we just want, can I use this or even better, can I use a relative path? Can I use a relative path like this? Cargo build. Did it work? Did it work just by doing that? Cargo run. Loaded image 0 by 0 and 0 channels. So at least it compiled, but it doesn't look like it's doing anything interesting. But maybe it has to do with the fact that this path that we are passing in here. So we are inside source main, and I want to print the current working directory. Print line. I think this is standard and current dir. Yeah, current dir and wrap. And is this printable? So the current directory is home, Alex, stream, Icaros. So it's this. And we have textures. Do I have a typo? Textures. Texture.jpg. What can it be? What can it be? What if I go up one directory just to try something? That doesn't seem to improve anything, because we got the program in the compiled program in target debug Icaros, right? We could even run it from here. and the working directory is the same. What if I go up 2 directories? And cargo run. Still zero. Standard. What else do we have in standard? Nothing here. Standard N. Current dir. The current working directory has path off. Temp dir. Not sure what we are doing wrong. Maybe just open the image. Yeah, I can see the image just fine. You don't see it, but texture, JPEG, width, height, channels 4. And what did we have on the STD? File name. Do we need this static? Let's read. Do they mention anything about the path? I just want to make a quick test. Test. Right. Include std image.h main. So basically what we have in here, but converted to, what did I call it? Oh, I did not say it. I did not say it. See that? Here I don't need this. And I don't need this. And I don't need this mute. And this should be printer. And now I can compile this. I'll save it. GCC test. Save it as test.c. And reference. Need to add the define. This and define reference to poll. Do I need to link with LM with the math library? Maybe. Looks like we do. And if I run test, we get the same problem. Why? Why? What am I doing differently? The only thing that they are doing different is that they don't assign 0 to these ones. So that was it. That was it. It cannot be. No, but no, we're still getting if I print here the pointer that we get back, is it meaningful? I just there are 2 channels, pointer or pixels. Oh, here I have so now we are getting something good. And if I set this to zeros, it should be still fine, right? Yeah, we still get something good. So what are we doing wrong here? Oh my god. Oh my god. Was that it? Was that it all along? No. We're still getting... Still not being able to load it. I need to debug this motherfucker. Target debug. Items, break, add line main arrays, line 412. Run. Oops. Need to rerun this. I just cannot see the difference between this one and our test. Textures, texture JPEG. So, what was the command to help run? I don't know. I just don't know. So, what else can it be? There's also, I think there's a crate. Crates, STV image. We could peek at what they are doing. Yeah, they use Bungeon, STV load, const cchar. We're doing this exact same thing. Cchar, cint. Const I32. What do they define? Oh. Oh. Oh, oh, oh. Ah, no, it's correct. We return a pointer. Do we need to tell it that extern C, they are not using the link directive anywhere. Extend crate, crate name, crate type, rlib. Do I need to make it a separate crate in order to link properly? That would be a shame. To me, it looks like a problem with the path, but if I do standard fs file open, it also takes a path. And I set it to textures, texture.jpg. Like F. Am I able to open this file? Yeah, I am. It's very weird. It's very weird. Is there any... We have also a std load from memory, so we could read the image. Let's grab this one. The only difference is that instead of a file name, we pass in, let me change all of this to be just isotopes. Yeah, the only difference is that we pass in a buffer of unsigned bytes and the length of that buffer. So we could even get rid of this, add extra bytes. and use the macro include bytes textures texture. Right, this one is relative to this file. Textures. And now we can use, let's comment this out and instead use stdi load from memory texture bytes as pointer texture bytes dot len and the rest the same. If byte channels and core looks reasonable to me. This one needs to be size 32. Huh. This one worked, so it's definitely an issue with the path. So how about oops. How about we comment also this one out? And in here, sorry about that. I meant to use here an absolute path. So that would be home. Home, Alex, Green, Icarus, texture. I don't get it. I'm an idiot. I'm an idiot. I was using... Please tell me that it's that. Please tell me that it's that. Yeah. Oh, I was going crazy. And now I can use a relative path, right? Yeah. So yeah, we need to use backward slash, not forward slash. just a dumb mistake that took me like half an hour or more, but in the end we got it. So now we can get rid of this, all of this. We load the image, we don't need to log this anymore. And now we can close all of this. And continue with the tutorial. So once we manage to load the pixels, I'm gonna add an assertion that assert that pixels is null and negate that, and then we can, I remember to end it with a semicolon. Then we can set the size as the width times the height times 4. So let image size is equal to width height times 4, because we said here that we wanted to have 4 channels. So even if the image doesn't have 4 channels, STV will convert it into 4 for us. So next we need to create the staging buffer and copy the data over, and after that we will be able to free the pixels. So I'm gonna call already free pixels. I expect this to require a cast. Yeah. As mute remote. It should work now. Then we need to create the buffer. I think we created this function as well. Create buffer. Why are you not helping me? Text in the device, physical device, the image size, I think, and the creation flags. Yeah, image size, and then this, and gives us back the staging buffer and the staging buffer memory. Then we can map and copy the data and free. So if I go to bk map memory, basically we want all of this. And paste it over here. But the real one. We map the memory for the staging buffer memory. The size is gonna be also the image size. Then we copy the pixels. And this should be mutable U8, I think. Times the size. And then we also need to unmap the memory. And after that we can free the pixels. This one probably needs to be U64. Hold on a second. I'm back, sorry for that. Image size, actually I'm gonna, okay, that size, force it to be, and here, well, we're gonna have to cast it anyway, somewhere. So it doesn't matter. Here it needs to be VK device size. Then we can get rid of this one. Get rid of this one. Now what? Here needs to be again get device size or U64, and here needs to be as U size. Check this. And right, to make sure we don't crash. Looks like we don't crash, but we do get some validation errors because we are not destroying this staging buffer. So I'm gonna add that to clean up this resources. And I really have to go now, so sorry for that. I will continue next time, and hopefully we can manage to see a texture on the screen. So thank you all for watching, and I will see you next time. Bye.